Welcome everybody to the next in the series of Responsible AI Network AI Standards Conversations with Standards Australia and the National AI Centre. Today we're going to talk about data-centric AI, which is absolutely my favourite topic to talk about. My name is Dr. Ian Oppermann, and I'd like to say welcome and also to acknowledge the traditional custodians of the land on which we meet today. For us here in Sydney, it's the Gadigal people of the Eora Nation. I'd like to extend my respects to elders past, present and emerging, and extend those respects to any Aboriginal and Torres Strait Islander elders who are joining us today. So this is the next in the series of standards about AI, standards today about data. And what we're going to do is look at data in an AI context from a medical perspective, from a robotics perspective, from a data privacy and impact on ethics perspective, and then use of data in decision making. And of course, what we're going to do is talk a little bit about standards of data and AI, and then we have an opportunity for a Q&A with our panel. So without further ado, I'm very, very pleased to be able to say that we, first of all, have an introduction from Rita Oriago, who's the Industry Program Manager at the National AI Centre. So Rita, over to you. And unfortunately, you're on mute, Rita.
Thank you so much, and thanks for the introduction. We're super excited to be hosting this webinar today. Data-centric AI is so important, and especially when you combine it with standards. It's also a really fun month at the moment. You'll notice my AI background, it's AI month. And if you join the National AI Centre's website, you can see a whole lot of different events that we've got coming up. And we have over 60. And I just wanted to share a couple of highlights in case you want to get more involved in AI month. We've got a virtual event with Tooth Fairy AI, a workshop on large language models and RAG architectures. We have the CEDA National AI Centre AI Leadership Summit coming up on the 8th of December. We also have some amazing training you could do with Amazon Web Services around the generative AI revolution, the Future of AI Summit at University of New South Wales in Sydney, and Invest Responsibly with AI coming up in Melbourne. So just some of those events that are coming up, and I'll let everybody else start discussing data-centric AI next. Bye.
That's wonderful, and it is really fantastic to be in AI month. And of course, AI month, we're running it from the 15th of November to the 18th of December, exactly 1 month, according to the calendar. Alrighty, now to get things warmed up, we're going to ask you a question as a poll. How familiar are you with standards for AI? And yes, it is a leading question. We are going to be talking about standards for AI today. We're trying to get a sense of just how familiar you are with them at this moment. So you should be able to vote on using the polling tool. And we'll have a quick snapshot of the results of that poll in a moment. Okay, we might have to come back to that one. Okay, we'll come back to that one. It was a leading question, as I said. All right, so as mentioned, our session today is really trying to look at data in an AI context, and we're trying to take that perspective from a range of different viewpoints: medical, robotics, data privacy, and use of data in decision making. And it is my great pleasure to say that our first presenter, data in my AI context from medical industry, is from Associate Professor Fatima Vafaei, who's the Deputy Director of the University of New South Wales Data Science Hub. And so, Fatima, over to you.
Thank you so much, Ian, for the invitation. And if everyone allows me, I'm just quickly share my screen. I have a couple of slides very quickly to go through them, and a bit of background on my research, which that would be a sort of segue to my discussion. So my screen should come up now. Can you see that?
All good.
All good. So a very brief introduction to myself. I'm Deputy Director of UNSW Data Science Hub, which is a university-wide center on data science and leading health data science priority area as well. I'm also have entrepreneurship hat on. I'm founding director of Omniomics AI, which is like a startup company working on disease diagnostics and drug discovery. and also team leader of Next Generation Graduate Program on Biomedical, basically medical and health technologies, which we are basically training a large cohort of students in AI applied to multiple medical and health questions in collaboration with industry. Very quickly about the research and development landscape of my lab, basically. So there are two main pillars of artificial intelligence and network science. Focusing on artificial intelligence, we're working on a variety of different methods, which is not my focus today, because we would like to sort of focus to data-centric AI rather than model-centric AI, but it's just to showcase that we are heavily using AI across multiple questions. And what are those questions? There are three main areas of research, which is AI-enabled disease diagnostics, drug discovery, as well as single-cell analytics. And it is in very close collaboration with multiple industries and health organizations, nationally and internationally. I do quite care about translation of the research that we do and how we can sort of make that available to end users. So making that work out in real world data is quite centric to our research. So why data standard matters in medicine and health? One of the main reasons that I would like to focus on my talk today is, or sort of my discussion today is about big and diverse type of medical data that we are dealing with. So today, we are collecting data from many different resources, and these data not only are big, they are quite diverse. There has been a study, I would say like over 5-6 years ago, that has been shown that genomics data, which is basically reading your 3 billion base pair of your DNA, which is within nucleus of all your cells, is taking the leading as compared to all other sort of big data domains, which is at the time Twitter, YouTube, as well as astronomy data, and has been shown that in terms of both generation and storage, it is the biggest area. And I would say that since then, the amount of data and technologies has been incremented and increased in terms of the throughput of the data, and we are really dealing on big data today, from genomics data, which is DNA, to reading all the proteomics, to reading all the sort of RNAs and other molecules, which we call it omics data, using next generation programming, next generation sequencing technologies, to many other types of data that you can think of. And that would basically help multiple AI models to answer many different questions in terms of diagnosis diseases, understanding how it is going to sort of progress over the term of treatment, how it responds to treatment, what is the toxicity of the treatment, and what are the different side effects, basically. And with this huge amount of data, there has been a lot of efforts to put this data together, from, for instance, Gene Expression Omnibus, which is one of the largest public repositories of data, which millions of researchers across the world submit data to that, to PRIDE, which is the proteomic sort of repository, which includes over 300 million of mass spectral reading proteins, to the Cancer Genomic Atlas, which is an international consortium of multiple types of data across different cancer types, to electronic health record. What I would like to focus here is that we are dealing with huge amount of data that without standards and without proper metadata to basically storage and share this data, that would be an absolute mess. And we wouldn't be able basically to use that for the next level, which is developing proper models that they are translatable. And I would like to have another emphasize that AI-enabled multimodal biomedicine is the future of the medicine. And this is how the medicine has been revolutionized within the next, for instance, decade, I would say, which we are collecting, and we would have access to many different types of data, from genomics data to microbes within your gut, to wearable biosensors or ambient sensors, environmental data, medical imaging data, among others. And basically, across multiple fundamental issues around data in healthcare, which you can think of interoperability, privacy and security, data quality, equitable data practices, as well as ethical concerns, which are very, very important in healthcare. What I would like to pinpoint here, which has been sort of a bit overlooked in the field, is data integration, and how important it is to have standards to be able to homogenize data across multiple different modalities and multiple different sources and multiple different data providers, to be able to effectively use that for these holistic multimodal AI models in the downstream. And I have provided multiple resources that can be shared later on. And this is me basically, Ian.
Wonderful and very well done from a timing perspective. Thank you very much, Fatima. So let's move on then. Our next presenter is Professor or Associate Professor Roman Marchand, who's the Head of Research at UTS's Human Technology Institute. Roman, over to you.
Thank you, Ian. Hopefully you can see me there. I've also shared some slides and also giving a bit of context to my talk in terms of how data science can be used for social change, actually, more than robotics. I mean, I've worked in robotics for many years, but we're looking at the perspective of how data science can be used to improve humanity and well-being. And through this process, actually, that I'm presenting in this slide, you can see how is our methodology and where data fits in a decision-making process for policy decision-making. So the most important thing is obviously starting with defining the problem. And I'll get onto specific details of data, but we don't want to start with the data and how we use the data we have to answer problems, but flip this on its head and say, well, we really need to understand what the problem is, work with academics, with experts and communities to understand what is the urge and what is the problem. Then go to the current beliefs. What do people believe? What are the current opinions and what are the different variability in terms of opinions that experts have and the communities have in terms of the beliefs of the actual problem itself, but also the possible solutions to this problem. And then you go ahead and collect the data. And this is a key insight, is we want to be able to collect the data that matters the most. It's not what questions you answer with the data you have, but what data you need to answer the questions that are relevant. And most importantly then comes connecting that data, and we'll get into the details about what the standards the data needs to follow in this regard, but it's connecting that data with models that are actually able to understand the causal pathways. You know, you can build machine learning models that find correlations everywhere, but the tricky thing is to understand how the data, different types of data, right, different modalities actually help you identify the cause and effect mechanisms, because that's what truly then, as you can see later in this diagram, updates your beliefs and ultimately informs, provides evidence for decision makers to act based on this evidence. Now, new policies will then be co-developed, co-designed and implemented within the communities themselves as well, which in turn will generate new data and update their beliefs as to what matters and what doesn't. So in terms of data itself, I wanted to highlight the importance of defining the problem and the beliefs before looking at the data. Otherwise, you end up being really kind of like exacerbating biases that are already existing in the data. And as I said already, it's not about the questions you can answer with the data you have, but what data you need. And so that's where you conduct surveys, focus groups, and link administrative data sets when you figure out what data you need to answer a question. And I also wanted to highlight the crucial importance of metadata. I've been in very tricky situations where we're dealing with data where we don't know, for example, how it's been pre-processed and how it's been linked. And so it's very important to work, and this is the last point, which is to work with actually the experts that were part of the data collection process, that were part of the social technical system that gave rise to this data, to understand its limitations, to understand what it can be used and when it can't be used. And if for data science and those actually using the data, they need to know the data journey from the time it was generated and it was pre-processed, collected, cleaned, and all that matters, because ultimately, as you will see in this cycle, the decisions will and the models you build will ultimately depend and reinforce any problems that are present in the data itself. That's my 2 cents. Thanks, Ian.
Thank you very much, and also great with time. Thanks very much, Roman. We're going to have another poll now. We're going to at least try one more poll, and you should see the link to the poll in the webcast. And the question is, what are the biggest issues with AI today? And hopefully you'll see a poll link come up. What are the biggest issues associated with AI today? And I've got a thumbs up, so that the poll is working, which is excellent. All right, now, whilst that poll is running in the background, we're going to move on. And the next in the Data in My AI context on data privacy is Dr. Thierry Rakoto Arivelo. And I'm terribly sorry, Thierry, if you would like to pronounce your name properly, you're very, very welcome to do so. But Thierry is the group lead on information security and privacy group software and computational systems program within Data 61 at CSIRO. Jerry, over to you.
Thank you. Thanks, Ian, and thanks for the opportunity to join this discussion today. Like Roman and Fatime mentioned earlier, data is at the core of AI and machine learning. Maybe next slide, please. Yes, so it's at the core of AI and machine learning. So there's tremendous amount of data that is required to train machine learning models, especially the most recent generative and conversational models that have been on the headlines recently. And so we all know that this data often have sensitive information, not just only about individuals, but also about businesses. So maybe what I would like to do in these 5 minutes is unpack a little bit the issues, the privacy issues around these sensitive informations. Maybe next slide. Next slide, please. All right. So the first issue that I wanted to maybe highlight is that often the actual risks, the actual privacy risks in data is not very well understood by data custodians. And we've had a number of examples of that in the past few years in Australia, where data that was supposedly de-identified, supposedly anonymized, actually was not. So removing personal identifiable informations like name and addresses is not enough. There are a lot of other information about an individual or business that can be used to re-identify or to single out these people in groups of these people or businesses in groups of others. And that's not helped by the fact that we've also had a lot of data breach. So that means there's a lot of these information which are not necessarily personally identifiable, that are out there from different breaches, and that can be used to piece together some quasi identifiers of an individual. So that's one of the main challenges. So understand privacy risks better. If you're looking at the AI model that have been built on top of the data, then there's also a lot of more recent challenges, more recent threats that have been mentioned and studied. And I'm not going to be, it's not going to be an exhaustive list because we can spend hours on that. I might just maybe highlight 4 of them. So one of the challenges, for example, is that there's a lot of machine learning models where you can attack them to extract the data that has been used to train them. And there have been examples of that in the recent literature. Even if your goal is not to find, to extract the data of the individuals of businesses that have contributed to the training of these models, you can still infer valuable information about these individuals. So for example, if you have a model that generates synthetic data, it has been shown that some type of attacks on these synthetic data allows you to find out if some information about individuals that have been used to train the models that generate this synthetic data. So that's another issue. We will talk, I guess, and we've Fatime mentioned that earlier. There's a lot of ethics issue with considerations with using data with AI model, and one of them, for example, is fairness. So how do you make your model, your classifier or predictor, be fair for different groups of people? So there is also issues there because privacy and fairness interact with each other. With the data and with the model. So by trying to uplift privacy, you might impact fairness in your model. And maybe the last point that I'd like to raise for discussions later on is that there are other fine-grained privacy rights, like the right to erasure, that are not very straightforward to implement efficiently in machine learning models up to now. So these are maybe 5 of the different challenges that I wanted to highlight today, and maybe we can discuss them later on in the Q&A. And that's me, Ian. Thank you.
Thank you very much, Thierry. So our next is data in my AI context is data and decision making, which with Professor Kimberly Wetherell, who is at the University of Sydney and the ARC Centre for Excellence on Automated Decision Making in Society. Kimberly, over to you.
On this panel, I'm the person who is not a data scientist, not an AI technical specialist. I'm a lawyer, and I come from the ARC Centre of Excellence on Automated Decision Making and Society, and it's that last bit that's important. I see my role on this panel as being to raise some points about data and its relationship to people and society that can sometimes be lost when we get all enthusiastic about what we can do with data. And the core message is that if you're developing AI based on data that is about or affects people, then don't forget that there are real people on the other side of that data. And those people will actually often be extremely favourably inclined towards mindful, high quality and careful use of data to generate insights that might help them, make their lives better or make the world better. But the favour and the trust is highly conditional. And this is something that the New South Wales government has so far been really careful not to lose sight of. Thinking back to the darkest days of COVID, I can remember how carefully calibrated the release of data about infection rates often was. We would get data daily on cases, and it was data that could have been very revealing about individuals, but it was really carefully vetted to make sure you couldn't narrow it down to particular people. So we felt informed, but it didn't invade people's privacy. Now, since we're here to talk about data-driven AI, I think it's really important to emphasise that based on my experience from a number of projects I've been involved in, that people's views about data can be really quite nuanced. There can be really strong enthusiasm for data and the insights it can provide. But that enthusiasm can sit right alongside strong beliefs about limits and the desire for a say about how that data is used. So, for example, I worked on a project with the New South Wales government regarding the National Disability Data Asset. So this is a big federated data asset relating to people with disabilities. And the call we heard repeatedly from organisations working with people with disabilities and people with disabilities themselves was that they really wanted good quality data. They knew exactly how much they needed the insights that could be generated from good quality data. But beside that was the call that there should be no data about us without us, right? They were unequivocal in their claim to a seat at the table for decision-making, but also for interpretation of that data and for their lived experience to inform interpretation, right? So they didn't want to just be consulted, they wanted to be part of the process. Now that was a big data asset, that call won't be practicable or sensible for every project, but it's worth thinking about. This leads me to what they were calling for was a really strong data governance framework, one that involved them. It does lead me to another important point, which is there's more to privacy than just keeping information confidential. Now, I go to a lot of technically oriented events. It's wonderful what people can do with privacy enhancing technologies. But my point here would be that privacy isn't just about making sure data doesn't get out. That's important. It's an important first step, and we all know that post-Optus, but it's only a beginning. Privacy is also about the fair and respectful treatment of data. It's respecting people's autonomy in decision-making, and it's about respecting social norms, I guess, about what data it is and isn't appropriate to use in different contexts. People out there, and if you investigate yourself, you'll find this too, have strong views about what data it is and isn't okay to use to draw conclusions about people. And it's a good check to think, well, how would I feel if these sorts of conclusions were being drawn about me on the basis of this kind of data? Where you don't respect societal norms, and as I say, people are often enthusiastic about the use of data, but within the expectation, within reasonable expectations, in a fair way, in a respectful way. The final thing I'd like you to bear in mind is the challenges of data quality in certain contexts. Now, everyone knows data quality is hard. We've already heard that in other presentations today, but not everyone knows perhaps just how different data quality can be across society and across different groups in society. ADMS research on the Australian Digital Inclusion Index has indicated that something over 20% of Australians are what we call digitally excluded or highly excluded, meaning that they have challenges of access, capacity to pay, and or lack digital literacy. So they just may not have affordable access to the internet on a reliable basis. First Nations Australians experience digital exclusion at higher rates. There's something like a 7.5 point gap in digital inclusion between First Nations and non-First Nations people. And it's over a 20-point gap when you talk about remote and very remote regions. In other words, a frighteningly high proportion of the population, especially rural, especially First Nations, does not have affordable, reliable access to the internet. And this has implications when you want to apply AI, right? First, data about people who don't have always on access to the internet is just not going to be the same as data about people who do in metropolitan areas. And secondly, you need to think about whether your services require good internet access, because across Australia there are these gaps, these lacuna, these yawning chasms, you might call them, where a digital first product will simply be experienced as exclusion. So none of this is to say that data-driven AI is a bad idea. Data-driven AI is a great idea. There's a lot of people who are extremely enthusiastic, and across society there's a lot of acceptance that we need to learn from information and do better always. But we need to do better and do better at the same time. We need to do so ethically. We need to do so mindful of people's privacy, mindful of people's rights, mindful of people's rights in some cases to be part of the decision-making process. So that's a starting point at least.
Thank you very much, Kim, for that. Now, finally, we're just going to very quickly talk about some standards themselves related to data for AI. Next slide, please. What we're going to do, of course, is give you this deck, or give you the recording, give you the deck as part of the takeaways from today's recording. And so some of this really is just to give you access to information that you can take away and hang on to. So there's a couple of really important artifacts that were produced by Standards Australia over the last couple of years. Last year, they produced the Data and Digital Landscape Map, which is a view of all the relevant standards which relate to data and AI and Internet of Things and digital twins, partly because each and every one of them intersects in some way, shape or form to help create the resources, the tools, the landscape, the scaffolding for the landscape of the data and digital landscape. That work is really something very useful because it not only gives an understanding of the scope of relevant standards, but also those standards which have been adopted internationally, those which have been subsequently adopted nationally, so within Australia, and those that are coming down the pipeline. It was a snapshot in time, but really extraordinarily useful to say, this is the scope of relevant standards. That's on the left-hand side. The right-hand side is a dashboard that you can access. Again, there's a link there that you can use once we release the pack, or you can search for Data and Digital Landscape chart, where you can also again see that updated view of those standards which are being developed, those which have been adopted, and those which are coming. And that's really important because it speaks to just how much activity is going on in this space right at the moment. There's also, of course, the standards specifically related to the AI subcommittee of ISO and IEC, the subcommittee 42. Yes, that number was deliberately chosen. Subcommittee 42 is specifically focused on standards for AI, and it includes use cases, issues related to data and data quality, management systems, and a range of other really, really useful ways to think your way into AI in general. But as AI is a use of data, also talk about the things you need to know and understand about data, the ways to think about appropriate quality, the ways to think about appropriate use of AI. Next slide, please. And those resources are available to you before, during, and after this meeting. I thought I'd spend just a very quick amount of time talking about some really important new standards which are under development, so almost ready to come out, on data quality for AI and machine learning. And that is the 5259 series. Dash 1, data quality and analytics for machine learning. So it's an overview, terminology and examples. Part 2, data quality measures. Really, really important. If you ever get into a conversation with someone around data quality, you'll very quickly realize you almost certainly mean different things depending on your background and domain. So being able to say, these are the measures, this is the framework to think about, is really quite important. Part 3, data quality management requirements and guidelines, and Part 4, data quality process framework. All really powerful ways to think about issues of data quality, specifically when thinking of your use case of AI and machine learning. Now, the next couple of slides I'm not going to address. They are just going to be part of the pack for you to take away as resources. So next slide, it's just a little bit about what's in those. So it starts to break down just the contents of it. So you've got a sense of how further reading and places you can go. Next slide. Similarly, for data quality measures, some elements of thinking about it. And having had a look at these standards, I can tell you they really, really are powerful models to help you unpack really what's meant by data quality in a context of machine learning and AI. Next slide, please. And it's also worth noting that there are some really good standards coming for metadata. So there's a couple of which have already been published. So that's the 11179 series, -2-30 series, and they talk about metadata registries. They talk about the classification of metadata, how to think about all the different ways to think about metadata, and also basic attributes of metadata. And again, if you ever get into a conversation with anyone around metadata, you very, very quickly realize that you will certainly mean different things unless you're referring to an international standard. And there's a couple more coming, metadata concepts and registering and mapping development process using concepts and usage of metadata, and data element exchange for a subset of this particular standards group. It becomes very quickly a very rich and complex field, but as you saw from the presenters, it's all ones and zeros, it's all data, but the context, the provenance, the chain of custody, the fitness for purpose are so remarkably different depending on whether you're talking about robotics or health or privacy, or as Kim was talking about, data which is being used to help understand and reform complex systems like the National Disability Insurance Scheme. So I think that's done for me for slides. And what we're going to do now, oh yes, if you could just all read this slide, I'll wait for you to read the slide. Again, it's a set of resources. These are coming. These are great metadata standards which are coming, which increasingly, when you think about your own use of data and AI, there are tools, very high-level tools, more detailed tools, ever more detailed tools that you can turn to rather than reinventing, rather than saying either it's too complicated, we'll do something simple, or saying, well, there's nothing out there. There are hierarchies of these standards which are really, really useful and powerful. Next slide, please. All right, so now we're going to have a go at the polls. Everything is running completely smoothly today, so I'm going to have one more go at the poll. What areas associated with AI need the greatest focus from a standards development perspective? And that's assuming, of course, that in that first question about are there standards for AI, you actually said yes and had some awareness of them. Now we're asking the question, what areas associated with AI need the greatest focus from a standards development perspective? And I'm looking to my colleagues for a thumbs up. Is the poll working? Poll's working. Okay, all right. Now, whilst we have questions coming in, so please do post your questions online, I'm going to ask our panelists, and Fatima, I'm going to start with you. Very, very different perspectives, and it was deliberately chosen to be so. Health, robotics, privacy, and things like major social reform. How on earth can we build common frameworks for sharing and using data? Is it possible? This is a leading question. Is it possible? Or what areas is it possible, and which areas must we have something really specific to the domain? That's probably a better way to ask it.
Making sure that I unmute myself. That's a very good question, Ian. And so a short question is yes, but a longer question is there are some dilemmas or some considerations here. So of course, there are multiple areas, as I sort of briefly elaborated on in healthcare, and multiple type of data. Some of them, they are not evolving very rapidly. For instance, think about electronic health record. While becoming electronic is relatively new rather than sort of non-digital type of recording of medical data. But like clinical information, demographic information, these are something that are relatively static. But in the field of healthcare, we have a lot of dynamically evolving data as well. For instance, think about next generation sequencing technologies that has been evolving and progressing and basically becoming more advanced quite rapidly. There are new technologies, biotechnologies platform that they are coming every day. And something that I have a lot of interest to and sort of would like to have that as open question to the people in the field as myself, that how we can define standards in this evolving field. There has been a lot of international efforts and national efforts in Australia to make a lot of types of more static health data standardized. And these types of sort of standards has been available in my slides as well as a pack for audience. But some parts that are more challenging are that when technologies are changing, how we can sort of progress with keeping standards, specifically at the stage of data generation. Again, another way to look into that, there are multiple stages of standards that we can think of, as you have like covered, Ian. It's from data generation to how sort of you share data, to how you sort of storage data, and what would be data retention. So specifically in the space of data generation, standards are evolving in next generation sequencing technologies. And this is something that requires active efforts and sort of focus groups to be able to revisit that and adjust the standards accordingly.
So I'm going to ask the same question now, Roman. I'm going to ask you, same question, your perspective. It's at one extreme, they're all ones and zeros, but the context and the uses of them make them so different. What parts can we standardize and which parts really must be specialized to the domain that we're operating in?
Well, the answer to this question is totally, you need to have specific rules or specific standards for different type of data depending on the applications, not just from a privacy perspective, as Thierry was elaborating on, but also the contents and the quality of the data mean different things in different domains as well. And there's different ways of measuring that quality and what matters depending on the domain. There's also different modalities, I guess, of data that have to be treated differently. And so, yeah, I mean, my short answer is that there needs to be a specific definitions around this quality measures for different domains.
Thanks. Very, not to build on the suspense too much, I'm going to ask you a variation on that question. How can we take data from one domain and use it in another, given that what we've talked about is the very, very different domains? How could you use cross-domain data? What's the mechanism that could allow that to happen?
Thanks, Ian. So maybe I would say that what it might depend on what's the utility we were expecting from the data in the other domain. So from one domain to another. So if we are looking at maybe in some cases it's really hard to get data. In some sectors, some domain, it's really hard to get data because of regulation issues maybe, or maybe just the data is not there to collect. So in these cases, you might want to maybe port data from one domain to another domain for sandboxing purpose, to try ideas, to try models, right? So in that case, something that you could try is generate synthetic data out of data from a different domain and port it to another domain to test these ideas, to do some sandboxing. So that's not maybe for production or using a model for making a real life service or a real life utility. It's more like to test ID, to design prototypes. So when you do that, you can explore the properties of original data in one domain and build models that will replicate these properties into synthetic data for another domain. So that's one way maybe of doing it. There's no universal mechanisms that will generate the right data for that. You have to look at case-by-case basis. But again, like I mentioned, it depends really of the utility you'd like to get in the domain where you're porting the data to. So in some cases, it might not make sense at all.
Great. And that's actually quite a legitimate thing to say. And it's the sort of thing that you really need to know and understand if you are trying to combine data from one sort of domain to another. Kim, you mentioned the National Disability Data Asset or the National Disability Data Scheme Reform. That's data from across many, many different parts of service providers and also people consuming services. How can we make those data sets come together? Again, thinking that what we're looking at is data from really quite different domains.
Can you hear me?
Yes, now it's great.
Shame we didn't solve that earlier, but anyway. Look, I think, I mean, the interesting thing about the National Disability Data Asset is that, you know, it is data from a lot of different domains. It's from health, it's from education, it's from different levels of government, et cetera, but it does have at its heart a common ground, which is the individuals that it relates to. And so finding ways to link through those individuals was at the core of the project, and having that kind of federated data set system with a spine that, you know, related to these individuals was the core of the project. Of course, that is precisely where privacy comes in, right? Because it's all about individuals and identifiable individuals. And so the key to making that work was all about having processes that respected the privacy and the governance at that connecting point, and then later being able to anonymize and remove identifying information. And so I suppose the short answer to your question is finding the common ground between these data sets, dealing with all of the privacy and governance questions around that common ground, and making, you know, having those systems in place. And then as a broader throwback to everything we've been talking about, being aware that the context of those different data sets might mean that you have to be very careful sometimes and test the inferences you draw, right? So what we do in these, you know, in data-driven processes is we do the analysis, we try and draw some inferences and conclusions, but then we have to go and test against the real world. And that's, you know, part of the process that Roman was talking about. And it's part of that, you know, what people with disability groups were raising with us in the course of that project, which is, you know, we want to be there at the interpretation stage, because through all of this process of linking and analysing, you might miss something. And so we need to be present, you know, at the beginning and in the process and at the end.
Great, thank you, Kim. Now I'm going to ask a question to our panel, which has come through the chat. Just if you could just put your hand up if you'd like to respond, just so we don't have people talking over each other. Now this is a cracking question. Everyone has faced this question. If you don't have access to data to train your AI, what's the best way to acquire some? And please don't throw your hands up in despair and say, oh my goodness, that's the fundamental problem of all researchers and all algorithms. If you don't have access to data, what's the best way to acquire some? Fatima, please.
So there are multiple ways, and this is something that we practice quite a lot in our field, because as Terry has noted, there are some fields which health in some cases applies. For instance, in the context of rare diseases, that access to data is hard, and in any context is quite expensive. So I don't answer to the question if you wouldn't have access to any data. Yes, synthetic data generation could be a possibility, but often it's very hard to rely on models that has been solely generated on synthetic data. But it can be quite helpful when it is combined with other strategies that we do work on, assuming that you have small amount of data. Whether the amount of data is small or the labeling cost is very high, so you have data but it's not labeled, are different things that you can sort of consider. But we are combining different strategies to handle this, from synthetic data generation that Terry covered to transfer learning approaches. When you have other related domains that it's easier to collect data from, and then build models within that domain and apply domain adaptation techniques or transfer learning methods to basically adapt to the new domain, because you have much less data available. Let me give you an example. For instance, if working in the context of cancer that I have been quite involved, there are more sort of common cancers such as lung cancer or breast cancer. There are some very rare cancers such as brain-related cancers. And if you would be able to use the model that has been trained on larger amount of data, but quite relevant, we're all talking about sort of different cancer types that they have a lot of commonality, and do transfer learning into more sort of restricted domain. This is another powerful strategy. But working out from like these augmentation, synthetic data, or transfer learning approaches to another aspect of that, which is very important, and this is collaboration and partnership. So if we would be able to come together and we'll be able to make connection with those that have the capacity, but everyone like a small, to generate data, and again, build the standards that we can homogenize data generation, collaboration and partnership would be quite effective to increase the data, the real world data, which then can be augmented with other strategies.
Thank you very much. Roman, I see you were next.
Thanks, Ian. I wanted to highlight that at least for us in the Human Technology Institute, starting with synthetic data is a must. We need to be able to validate that our models are actually able, and I mean AI and machine learning models, statistical models, are actually recovering the data, the true data generation process, and that you only know the true data generation process when you generate the data yourself. So we usually start by training AI models with data that we know where it was generated, and we evaluate if our models are able to actually recover that synthetic data. And only when we're able to do that to a certain extent, and that's another, I guess, conversation in itself, how do you measure the performance of these AI models on this synthetic data? Once you feel comfortable, then you go ahead and seek access, I guess, to other sources of data, real world data, to train your models. Now, this was also part of the question in terms of acquiring the data. And I think there's a lot of, startup companies and even large enterprises that see a lot of risk in hosting large amounts of data, private data, that it is really very sensitive information, right? And so it's not, and I think the government is moving in the right direction in terms of hosting actual interfaces like MADIP, the multi-agency integration data platform that allows you then to access the data in a secure environment and run your analytics on their own server, so the data is not leaving that original space. So it's not really acquiring, as in getting a copy of the data, but analyzing it in a secure environment, which I think is where we need to move towards as well.
Thanks, Roman. And I have to say both the answers so far to this question touch on a level of sophistication, or levels of sophistication, that I think would be quite advanced for many different users. But the point about collaboration and the point about working with others in these different domains, I think is a very simple takeaway. Thierry.
Thanks, Ian. I think Fatime and Roman covered a lot of different possibility there. And maybe just one thing that I wanted to add is that in some cases, this access to the data is not possible because of trust through the data custodians or the data source of the people that generate this data. And another tool, another family category of ways to address these things is distribute the building of a machine learning model, distribute the building of the AI directly to this source. I think Roman hinted to that as well towards the end of his response to the question. So basically, there are families of techniques where rather than train a machine learning model centrally, you can ask different participants to train them locally and report back just their fraction or their part of the model trained on their data. And in that way, the data does not leave each individual participants. And there are technical ways to make it so that these different parts of models actually preserve privacy. So that's called federated learning, or privacy preserving federated learning, and that's another something else that can be used in this context, I think.
Thanks, Jerry. One of the things we might do for folks after this, when we release the slide deck and the recording, we might actually identify a few places or suggestions for where to go next to learn more about some of these topics. Because again, Jerry, you're touching on a really sophisticated set of approaches to thinking about how this goes forward. Now, we've got a question from Phil Argy. Great to hear you're online, Phil, about data standards from a particular organisation called NAIC is developing for e-conveyancing. And the question is, are they bespoke or an adaptation of general standards or not real standards at all? I'm just going to say that there are many, many groups around the world who create standards. The standards that Standards Australia lines up to are principally ISO and IEC from an international standards perspective, but also there are standards development organisations who receive accreditation from Standards Australia. And all of those accredited organisations can create standards that become national standards. There are a whole lot of other groups who are not either members of Standards Australia or who are not contributors to those major international standards bodies who do actually create standards which are outside of that ecosystem. That is one of the challenges when picking which set of standards you want to go with. The Australian position principally is ISO IEC and those organisations who are accredited by Standards Australia. So the answer to your question, Phil, and again, great to hear you again, is that as far as I know, NAIC is outside of the Standards Australia membership. We had a question from Harry Priya, Harry Kumar. Thanks very much, Harry Priya. How well can we such synthetic trained models or transfer learning based models to generalize well to real world data? And again, I think this is one of those really, really fine domain questions, which Fatima, I'm going to throw to you. How can we trust those? And do you have any evaluation measure for that?
That's a very good question and very tough to answer, basically. So
That's why I threw it to you.
So the practice that we take on, specifically when it comes to translation and generalizability and to diverse domains like humans, that everyone is different from others, is that we use a lot of these approaches, for instance, synthetic data generation. But a bit of backtrack, I think the person who has asked this question have this sort of background, but I will give a few seconds of background on this, that we often, when we want to evaluate data, we split data into two different parts. One is the one that we use for training and optimizing the model, and the one is another part is the one that we use for validation. In my domain, I never use synthetic data or non-real data for ultimate validation or, for instance, external validation. We use that for optimizing the model and improving the model, for instance, generalizability, but later on evaluate that on real data. And this is very important. And we have been frequently seeing that once we get this strategy to improve the data quality or the data amount or the data balance using synthetic or other approaches, the performance on evaluation data, which is all real data, has been improved. So short answer is that we trust on the metrics that has been reported on real data, but can compare that how the synthetic data can help the performance on real data. And this is quite comparable, basically.
Right, fantastic. Last question. I want to save just a little bit of time to get final thoughts from all of you. But last question for Kim. I've got a really, really difficult one for you, which if you could give us a succinct answer to. Again, I'm coming back to this National Disability Data Asset. Really powerful data set, fine-grained detail about people in vulnerable circumstances. How can we apply an ethical lens to analysis of that data? And especially when we're thinking about application of AI, and I'm sorry, I'm not giving you a lot of time, but if you could at least frame a way into thinking about how you could apply an ethical lens to that.
That is $1 million question, honestly, and it's not one that's easily answered shortly. But as you say, there are ways into this, right? I mean, we do have a whole set of principles, including the Commonwealth Government's AI ethics principles, that give you a starting point for thinking about what is ethical use of AI. And so, paying attention to those principles and acting like a normal and reasonable human being is a really good start. But another point that really came out of our work on that particular project, I mean, and there's a reason we titled that report, No Data About Us Without Us, which is that, a core concern in analysing this from an ethical frame is really engaging with the people who are affected, right, and paying attention to their perspectives.
Thank you very much, Kim. That was very well done in a couple of minutes. Now, we're going to go just final run through in order of our presentation. So Fatima, you're first. What are the final takeaways for people? We've been talking about all these different wonderful uses of data in AI context. What are the things you need people to remember as they leave today's session?
Well, one sentence takeaway would be standards are very important in health and medicine. And adding to that, there are sometimes difficulties to comply with the standards, but it substantially improves the performance, usability, adaptability, and translating of that to the real world once we comply with the standards and generate data based on the standards.
Excellent. Thank you very much, Roman.
Thanks, Ian. I would like to highlight the need for transparency in the way that data is pre-processed before it's distributed. Firsthand, we've encountered problems where we think we're getting data that represents something, and it doesn't, right? And it's completely off. And it's been pre-processed in a way that changes the decisions that you make with that data. So reminding everyone that the quality of the data truly matters, and it's a fundamental part of how decisions are made that are evidence-driven. And so it's important to be transparent and to build also models that make use of that data in the best way possible to understand cause and effect.
Thank you very much. Thierry?
Maybe one of the takeaway message I'd like to point out for this session is that it is quite important to objectively understand the sensitivity of the data that you are using, and not leave that to just impressions or So really go through a process to put some numbers and to be confident about the sensitivity of the data and what can be done to desensitize part of it. Because on one hand, you might end up, there are organizations, I guess, that are looking up data, and that prevents innovation and that prevents lots of societal benefits. And on the other hand, there might be some other entities that are maybe sharing much more than what they should. So I think that's a takeaway message that I like is get a very objective and systematic idea of how sensitive is your data.
Thanks, Thierry. And Kim, if you could bring us home.
The same message I have been putting forward the whole time, even if you couldn't hear me, which is that there are humans behind the data and human contexts around the collection of this data. And so like this, I absolutely agree with what people have been saying, that standards are really important, and the data is pretty useless unless it does follow good standards. But the people around and the context around it are also critical to making sure that we use data in an ethical way, because all of our research shows us that people want the insights from data. They just want to know that it's being done ethically, appropriately, and isn't going to hurt them.
Thank you very much, Kim. Thank you. Very, very, very well said. So today we've talked quite a lot about data in my AI context, and those AI contexts are very, very different depending on the domain we're in. But if you don't have the metadata, the data about the data, or you don't have an understanding of your data quality, it's extraordinarily difficult to appropriately use that data in that AI context. So thank you all very much for joining us today. We had a few technical hiccups, but that's the way the world works these days. But we will release the slides and the deck and the video a little later, so you'll have access to that. We're going to ask our panelists if they could assemble just a couple of further reading points, and we'll include that in the slide deck, so you've got somewhere to go and pick up the richness of that conversation. And of course, soon we'll have from Standards Australia and the Responsible AI Network a data-centric AI white paper coming out. for those that have been following the white paper series, they are excellent, really, really good, and start to give you some of those resources that we're talking about. The recording of this event will be shared as soon as we might try and see if we can tidy it up a little bit, but we'll share the recording of this event. And we have another webinar planned for the first quarter of 2024. So thank you all very, very much for joining us today. Thank you for your questions. Thank you for your active participation. And thank you to our panelists for very, very insightful and thoughtful presentations. Thank you.
you, Ian, and thank you, everyone. It's interesting, on this panel, I come from quite a different perspective from the other speakers you had, not only because I don't have slides, but also because I am not a data scientist or a technical specialist.
Kim, Kim, just 1 second. There's a little Dalek-y noise coming from your microphone. I'm not sure if it's only me, but if I actually just press on, I'm not sure what we can do about it. Just press on.
Okay. I will press on. I'm not sure if we can fix that. So I'm a professor of law and also researching with the ARC Centre of Excellence, as Ian mentioned, and that last bit is really important. I see my role here as being to raise some points about data and its relationship to people and society that can sometimes be lost in all the excitement that we have when we have access to data and tools to analyse it. The core message is that if you are developing AI based on data that is about or that affects people, that affects people, you need to make sure that you don't forget that there are real people on the other side of that. And those people will often be really favourably inclined towards the mindful, high quality and careful use of data to generate insights that can help them live their life better. But the favour and the trust is highly conditional. What data standards can tell you what to do, but I'm here in part to tell you why it matters. This is something that New South Wales government's been really careful to lose sight of. Thinking back to the early days of COVID, I remember how carefully calibrated the release of data about infection was. Information was given to us, but it was given with New South Wales government avoided presenting that data in a way that could be narrowed down to individuals. And I can speak here to the project I did with the New South Wales government, our national disability data asset involving focus groups and interviews with people with disabilities. The calls we heard in that report and in that project were absolutely clear. People with disabilities understood the need for data and its use, but there were also two related points that were raised. First, that better quality data is urgently needed. People we spoke to, pointed out to us that data sets on people with disabilities were often incomplete, in part because people don't always report have a disability in different contexts where they don't consider it relevant. So when you link the data, it can look like it's inconsistent. That's really important. Like, this is the human side of data collection. Secondly, they were unequivocal in their claim to a seat at the important decision-making tables. I think it's important that their lived experience inform not just data collection, but also interpretation and even day-to-day management and decision-making. I can give you another example, human side of data that's important. Research at ADMS indicates that something like 24% of Australians are digitally excluded or highly excluded, meaning that they have challenges of access, capacity to pay, or lack digital literacy. It's even greater with First Nations Australians. In other words, a frighteningly high proportion of Australians don't have access to the internet. It doesn't take much imagination to work out that the impact it has on data about those people. The data about their everyday activities is different to someone who lives in Sydney. And so it's this human side you need to take as you're thinking about collecting data, analysing data, making decisions. The gaps might be there in human intersection between human and data. The final point I want to make is to privacy, and that is to remind people that privacy is more than sometimes as it's presented in technical circles. It isn't just about protecting data from getting out. It's about using data in a way that respects people's autonomy and right to make decisions about their data. So they care about how you use data, even if it never leaves your servers. So think about that also as you think about data. I'm sorry about the sound issues. I thought we had that sorted to this starting.